In this video, we're going to talk about radical equations, and these are just equations with radicals. We have to be a little bit careful. If there's two radicals in an equation, then it's going to be a little bit more steps. But the first thing we always want to do is we want to isolate the radical. Get the radical on one side of the equal sign by itself. Then we're going to raise each side to the power of the index. So if it's a square root, we're going to square both sides. If it's a cube root, we're going to cube both sides. If it's a fourth root, we'll raise both sides to the fourth power. Then we're going to solve whatever's left. Here's the thing. We have to check for potential solutions. Make sure that they actually work, okay? Sometimes they will, sometimes they won't. Just like whenever we had the rational equations, we had to check against that denominator. Here we're also going to have to check these as well. So the first one that we have is x minus the square root of 4x plus 12 equals 0. So I want to get this thing by itself. So I'm going to add this entire thing to both sides of my equal sign. And so when I do that, those cancel, leaving me with an x equals, well, 0 plus anything is just that thing. So this one was kind of nice because now I just have a radical equal to something else. I'm going to raise, now that I have the radical by itself, I'm going to raise each side of my equation to the square because this is a square root, okay? So that's going to give me x squared. Remember that the square and the square root cancel. 4x plus 12. Now we have solved several of these, so we're going to move everything to one side of the equal sign. So I'm going to get x squared minus a 4x because I've got to move it across, minus a 12 because I've got to move it across as well, equals 0. So I've got x squared minus 4x minus 12. At this point, you can use either factoring or the quadratic formula. Doesn't matter to me which one you use. I'm going to use factoring. Two numbers that multiply to give me negative 12, that add to give me a negative 4. That's going to be a negative 6 and a positive 2, because negative 2 times positive 2, negative 6 times a positive 2 gives me a negative 12. Negative 6 plus 2 gives me a negative 4. So now we're going to set each one of these factors equal to 0 and solve. So x is equal to 6 and x is equal to a negative 2. So we have our two possible solutions. We need to check it in our original equation. So when we check, x is equal to 6, so that's 6 minus the square root of 4 times 6 plus 12 is equal to 0. And I apologize, I don't know what's going on with my computer. So 4 times 6 is 24 plus 12. I'm going to take the square root of that answer. 24 plus 12 gives me 36. Well, the square root of 36 is 6. 6 minus 6 is 0. So x equals 6 is an answer. Let's check, because sometimes they both may work, sometimes one, sometimes neither of them. Okay, so let's check x is equal to a negative 2. So that's a negative 2 minus square root of 4 times a negative 2 plus 12. Does that equal 0? So let's see here. 4 times negative 2 gives me a negative 8 plus 12. We got to take the square root of that. Negative 8 plus 12 gives me 4. So I've got a negative 2 minus the square root of 4. Square root of 4 is 2. Negative 2 minus 2 is actually a negative 4. which those do not equal. So x equals 6 is my only solution for this particular rational equation. Let's look at another example. Here we have two radicals. We have the square root of 3x plus 1 minus the square root of x plus 4 is equal to 1. So what we're going to do is we're going to isolate one of these radicals. So I'm just going to add the square root of x plus 4 to both sides. So on this left-hand side, I strictly have square root of 3x plus 1. On this left side, on the right side, I actually have 1 plus the square root of x plus 4. So this one means I've got a radical on both sides, and I've got something outside the radical, so this one's going to take a little bit longer and a little bit more work. These are squares, so I'm going to square both sides. Be careful, I don't square each of these individually. I have to take this as an entire group. So what that's saying is I've got 1 plus the square root of x plus 4 times 1 plus the square root of x plus 4. So that means I'm going to end up having to FOIL these together. Now on the left-hand side, the square and the square root cancel, so I'm left with 3x plus a 1. Okay, on the right-hand side, what happens is I've got 1 times 1, which gives me 1. 1 times this square root over here gives me just that square root. Then I have the square root times a 1, which is just going to give me that square root again. And the square root times itself, so that's the square root of x plus 4 squared. On the left-hand side, I still have that 3x plus 1 sitting over there. So I'm going to combine some like terms. The square and the square root, remember, cancel each other out. So I'm left with 1 plus, I have this plus this, so that's 2 times the square root of x plus 4. And again, over here, these canceled out, so I just have plus x plus 4. These do not combine with these because this right here is still underneath that radical. On the left-hand side, I still have 3x plus 1. Now I'm going to combine the 4 and the 1. So I'm going to have a 2 square root of x plus 4 plus an x plus a 5 because I combined this 1 and this 4. Okay, I've got a radical still left in my equation. So I'm going to try to isolate it, get it by itself. So I'm going to subtract an x from both sides, and I'm going to subtract a 5 from both sides. That way these cancel. And so 3x minus x gives me a 2x. A 1 minus a 5 gives me a negative 4 is equal to 2 square root of x plus 4. If you can, go ahead and divide both sides by that leading coefficient. And whenever I do this, notice I did it to every single term. That way those will cancel, leaving me with an x minus 2 is equal to the square root of x plus 4. This will actually be much easier in the long run. Okay? So whenever I square both sides now, remember the square root with the square cancels. This, I have x minus 2 times an x minus 2. So if you need to, go off over to the side and do x minus 2 times an x minus 2. So that's going to give me an x squared minus 2x minus another 2x plus a 4. So that's x squared minus 4x plus 4. So that's x squared minus 4x plus 4 is equal to x minus 4. Now I'm going to move everything to one side. So I'm going to add a 4. Oh, hold on. I accidentally changed the sign. This should be an x plus 4 here. So I actually need to subtract the 4 from both sides. And subtract this x. So that is going to give me an x squared minus 5x. Those cancel, these cancel, these cancel, equals 0. So I factor that out. X minus 5, notice I just took an x out of both of them, is equal to 0. Set each of these equal to 0. Add 5. So x is equal to 5, and x is equal to 0. Now when you plug this back in, you have to check each one of them. So plug in the 0 and plug in the 5, and you'll find that x equal to 5 is your only solution. I'm going to leave it for you to check and figure out why. Try some of these with the radical notation, and then let me know if you have questions.